Problems 15 and 16. Solutions for this problem you can find below this video on the description. The following figure is used for questions 15 and 16. A small block of mass small m is moving on a horizontal table surface at initial speed v0. It then moves smoothly onto a sloped big block of mass big M. The big block can also move on the table surface. Assume that everything moves without friction. Question 15. A small block moving with the initial speed v0 moves smoothly onto a sloped big block of mass big M. After the small block reaches the height h on the slope, it slides down. Find the height h. And question 16. Following the previous setup, find the speed v of the small block after it leaves the slope. Solutions. Let's see. First of all, for the question 15, we can do a lucky guess for this height, because block M and M, they have some kind of mass, so it means that when this small block reach the highest position, they will move with the same speed, but this speed will be not zero. It means that this height must depend from masses, and the answers A and E, they don't depend from masses. And now let's compare the three other answers. Suppose that big M has a huge mass, so it means that after interaction it will almost not move. It's like motion of small block on the immovable other block. So it means that here we can use regular energy conservation and find what is the height of this small block, because it will not move, not vertically, not horizontally on the very top. So it means that here we have an answer that h must be equal v0 square over 2g, and which is looks like C is a correct answer, because for very big M, this answer is going to v0 square over 2g. But let's do it correctly. So we have to write equations for momentum conservation and for energy conservation. For momentum conservation we have this expression. We have initial momentum, which is m small multiplied by v0, that's equal m small plus m big multiplied by speed of center of mass, because in the highest position they have the same speed. That will be speed of center of mass. From here we can find what is the speed of center of mass. That will be this expression. Now let's write energy conservation. For that we have formula. Initial kinetic energy of the first block, 1/2 m v0 square. That's equal potential energy for this block, mgh, plus kinetic energy for these two blocks, which is 1/2 small m plus big M multiplied by v center of mass square. And now we can count what is height h. This is the calculations. We have mgh equal 1/2 m v0 square minus this one, which is 1/2 m plus m v center of mass square. Now we can insert expression for v center of mass, and finally we will get this answer. And now we can get the answer. h equal v0 square over 2g multiplied by big M over small m plus big M, which is answer C. This is the same as we mentioned before. Now let's do question 16. Following the previous setup, find the speed v of the small block after it leaves the slope. Now we can mention that this interaction between a small block and big block, that's the same as absolutely elastic collision. Only difference that for absolutely elastic collision we have instantaneous collision for a very short time, but we are not losing energy and momentum. Here interaction is going in a time, but result will be the same. We still have energy conservation and momentum conservation. And like for absolutely elastic collision, they will move out of each other. So we can use the same logic as for absolutely elastic collision. And remember that for such kind of collision we can use approach of center of mass. And we already found what is the speed of center of mass. That's this one. And if we go into this frame of reference of center of mass, in this frame, small block and big block, they are coming to each other with some kind of velocities. But after collisions, these velocities just change the sign. And they will go back with the same amount of velocity, but a different sign. And let's count what happened here. So now we can find what is the speed of this small block in the new frame reference of center of mass. That will be this expression v0 minus speed of center of mass, which is big M over small m plus big M v0. After absolutely elastic collision, this velocity just changed the sign. So we can write this one. That will be velocity of this small mass after collision. And now we have to return to our initial frame of reference. So it means that for that we need to add to this velocity of center of mass. So that will be this expression. And now, because mass big M greater than small mass, it means that small block going to the left in the negative direction. But the question is about speed of this block. So we just need to neglect this negative sign, and answer will be E, big M minus small m over small m plus big M multiplied by v0. That's the answer.